Here are our objectives for today for section 4.2. Section 4.2 deals with logarithmic functions. Okay, so first we're going to be able to change from a logarithmic function to an a logarithmic form to exponential form. And then we're going to be able to change from exponential form back to logarithmic form. Then we're going to be able to evaluate some logarithms. We're going to be able to use some basic logarithmic properties. We're going to graph them. We're going to find domains of the functions. We're going to use common logarithms, and we're going to use natural logarithms. Okay? These are our objectives that we will get to today. All right? So first of all, logarithmic to exponential form. Okay? Excuse me. So first thing I need you to know is that y equals log base b of x. Okay? Two ways to read this. One of them is the way that I just read it, y equals log base b of x. Another way that I've heard it said is y equals log of x base b. I don't care which way you say it. I say log base b of x because that's how I was taught. Okay? To me it seems logical because it's left to right and then you don't forget what your base is. But I've also heard other intelligent professionals say log of x base b. So it's really personal preference. Okay? This statement, though, in logarithmic form is equivalent to base b or b of x, b raised to the x power b raised to the y power equals x. Okay? So I want you to notice a couple things. The base of the logarithm is the base of the exponent. Okay? If it's a base here, then it's a base here. All right? Another thing I want you to notice is that what this equals is the exponent. Okay? What the logarithm equals over here is what the exponent is over here. In logarithms, these things are called the arguments. Why? I have no idea. Okay? But that's what it equals. That's what this over here equals right there. Okay? So we just have to be able to go back and forth from things like this. Okay? So if I say 2 equals log base 5 of x, could you rewrite that into exponential form? Well, the base here is 5, so that's the base over here. The power is what it equals to, what it equals to over here is the power over here, and the argument is the answer over here. So we could actually solve that right off the top of our head, but looking at this side, we couldn't solve that, could we? Okay, but I know what 5 squared is to solve for x over here, don't I? Okay. Log base m of 2x equals 7. Can you rewrite that in exponential form? Well, the base over here is the base over here. What it equals to is the exponent, and the argument is what it equals to in exponential form. Okay? Now, that's not something we can solve because there's two variables right here. But I didn't ask us to solve it. It just asked us to rewrite it in exponential form. Okay? So can you go the other way? Because first of all, it says go from logarithmic to exponential. Can you go backwards from exponential to logarithmic? So 6 squared equals 36. Can I write this in logarithmic form? Even though that's a statement we already know is true. Well, the base over here is the base of the log. The answer over here is the argument. And then the exponent is what it equals. Hard or easy? Pretty easy. Okay? Next, we need to be able to evaluate some logarithms. Okay? Now, this word evaluate means different things in math at different times. Okay? Typically, if we're evaluating something, we're saying f of x equals blah, 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 find f of 2. Right? We even did that yesterday, didn't we? Today, it's just asking us to tell what they mean. All right? If I tell you right now log base 2 of 16, I need you to be able to tell me what that equals, like pretty quickly. Okay? So here's what I want you to know. There's some they're definitely not tricks. They're just kind of shortcuts. Okay? Could I rewrite 16 as 2 to the 4th? Would that be okay? Okay? So I know that log base 2 of 16 equals log base 2 of 2 to the 4th power, right? So the thing about it is, when the base and the base are the same, guess what the answer is? It's the exponent. It's what's left, right? So that answer is 4. But here's what's interesting. If I just took this form right here and rewrote it in exponential form, I need it to equal something. So let's make it equal x, because we don't know what it is yet. That's what we're trying to find. If I wrote 2 to the x power equals 16, well, 2 to what power equals 16? The 4th, right? Well, I already figured that out by rewriting it so that my base is matched. So what I'm trying to show you here is that there's multiple ways to do this. Okay? You can rewrite it this way. You can rewrite it this way. Either way we do it, we're going to get an answer of x equals 4, if we do it correctly. Okay? So what about log base 7 of 149? Well, if we rewrite it in exponential form, that gives us 7 to the x power equals 1 over 49. Well, I know 7 squared is 49. Does that help me at all? Well, you got to remember exponential rules, right? If I need 1 over 49, then I need a negative exponent. Okay? So I know that x is going to equal negative 2. Because 7 squared is 49, but I need it 1 over 49, so I make it negative 2 to have that, that fraction there. Okay? Now, I could rewrite it exactly like I did up here, try to make the bases the same. So log base 7 of 7 to the negative 2 power. Still, what is our answer going to be? That exponent. That's the same thing as I got right over here. You see what I'm saying? That there's two different ways, at least two different ways to do this problem? Okay, so that's what it means by evaluate. So what about this one? Log base 25 of 5. Well, let's rewrite this in exponential form. 25 to some power equals 5. Well, 25 to what power equals 5? That's a good guess. What I need to do is take the square root of it, right? I need to take the square root of 25 to get 5. What exponent means square root? 1/2. Okay? So x equals 1/2. It's okay. Good guesses. Okay? Same, if we tried to rewrite it in like bases or make the bases the same, that's not as easy here because of the fact that this is the one that I need to adjust and not the one in the argument. Okay, so this one's probably the best way to do it is rewrite it in exponential form. Okay, one more. Log base 2 of the 5th root of 2. Well, remembering if I write log base 2 of 2 to the 1/5 power, that one's pretty easy to see that it's 1/5 would be my answer, x equals 1/5. But if I rewrote it in exponential form, 2 to what power equals the 5th root of 2? Knowing that 2 to the 5th power, or excuse me, 2 to the 1/5 power is the same as the 5th root, now it's really easy to see that the answer is 1/5. Okay? Excuse me. Any questions on evaluating logarithms? Okay? Using basic logarithmic properties. Okay? Basic logarithmic properties are some of the ones I was just trying to show you right now, but the really basic ones that they want you to know are, first of all, for example, log base 7 of 7. Well, think about the one I just showed you. If the base and the argument are the same, what's the answer? The exponent. What is the exponent here? 1. So guess what this equals? 1. So log base 5 of 5, what's that going to equal? 1. Log base 12 of 12, what's that going to equal? What? So anytime the base and the argument are the same, it's going to be 1 for the reason that the exponent is 1. Okay? Log base 5 of 1 equals what? Well, if I rewrite this in exponential form, I get 5 to some power equals 1. It is 0 power. That's the only power I can get any of this to make it equal just a 1. Okay? So log base 7 of 1 is going to equal what? 0. Log base 12 of 1 is going to equal what? 0. So when the base is anything and the argument is a 1 and you're trying to solve it, it's going to be a 0 because that's the power in exponential form. Excuse me, that's the answer in exponential form. The only power you can raise something to make it be 1 is a 0. Okay? Okay. There's also the inverse property of logarithms. Okay, so when we're working on basic properties of logarithms, that's one of them. Okay, these are like super basic properties. Then there's the inverse property of logarithms. Okay, inverse property of logarithms. For b is greater than 0. And also b not equal to 1, okay? Log base b of b to the x power equals x. Well, that's one I've already been telling you, but I'm just making sure you understand the actual, like, written mathematical property, okay? b, log base b of x is going to equal x. So what I said earlier was when the bases are the same, the answer is going to be the exponent, right? But that also works here. When this base and this base are the same, the answer is in the exponent. It's what's left right there. Okay? So if I say log base 7 of 7 to the 8th power, what does that equal? When the base and base are the same, the answer is the exponent. So 8. 3 log base 3 of 2x. What does that equal? When the base and the base are the same, the answer is right there. Any questions about that? Okay. Graph. We're not going to do a whole lot talking about this because of the fact that you are so amazing at transformations. Okay? Graphing logarithmic functions, again, we're talking about transformations. All right? But just to make sure you remember all the stuff. Let's put an A in green right there. I don't want C, I want an H. Pretend that's an H. What does A cause to happen in this transformation? It's a stretch or a shrink depending on the value of A. It could also cause a reflection, right? Over the x-axis, depending on the sign that it has. Positive stays the same, but a negative causes a reflection over the x-axis. What about the H? Horizontal shift. Left or right. What about the K? Okay. Now, I did forget one. Where does it go? It goes right here. Okay. If it's a multiplier on the inside, what do you think that's going to cause? It is horizontal. Also looks like it's time to throw that pen away. I will do that now. Okay. Any questions about graphing logarithms? Okay. What about domain and range of logarithms? Do you remember what the parent function looks like for a logarithmic function? It does? basically something like that. So where's the asymptote? Yeah, the y-axis, right? The y-axis is the asymptote because it's going to get closer and closer to but never touch it. Okay? The parent functions will, no matter what the base are, the parent function will go through that point. Why is that? Log base 2 of x. I'm saying it'll always go through the point 1, 0. So it would be log base 1 equals 0. Is that a true statement? Because 2 to the 0 power equals 1, right? No matter what the base is, if it was 5 or 10 or 12 or anything, no matter what the base is, it's going to go through the point 1, 0 because x is 1 and y is 0. Everybody understand? So when we do the shifts, the transformations, that's the point we move. Do you remember when we talked about yesterday the exponential functions? What was the point that we moved yesterday? 1, 0. 0, 1, right? 0, 1. That's the point we move for exponential. So do you think that these two might somehow be related? Yes, of course they are. That's why we're doing them together. But I don't want to ruin it. We'll talk about that eventually. Okay? So finding the domain. What's the domain of this function? How far to the left does it go? So from 0 on, but it doesn't get to 0, right? So I could say x is greater than 0, or I could say from 0 to infinity with a parentheses and not a bracket. Does that make sense? Now, the rest of it is just figuring out where you shifted it around, right? So if I say f of x equals log base 2 of x plus 4, what's my domain? Let me scoot that up, I'm sorry. What's the domain of this function right here? Well, where did it go? Yeah, it went left 4, so x is greater than negative 4, or from negative 4 to infinity with a parenthesis on the negative 4. Okay? Shifting it up or down, what does that do to the domain? Nothing compared to its parent, right? It's still greater than 0. Stretch or compressing it, what does that do to the domain? Nothing. Only horizontal shifts are going to change the domain, right? Okay, any questions about that? Okay, common logs versus natural logs. Common logs versus natural logs are not a hard thing. We kind of talked a little bit about this yesterday, but we'll focus just a little bit more on it today. If I say log of 2x equals 5, what's wrong? I don't have a base, okay? But I do, you're right. Why do you know I have a base? Because it's the most common base that we use, so we don't have to write it. Just like when we're writing x. What's the coefficient in front of this x? 1. You just know that, right? It's understood. What's the exponent on this x? 1. You know that. It's understood. What kind of root is that? It's a square root. I don't have a little baby 2 in front, but I know it because it's the most common use of that symbol, right? Same thing here. What is the most common base that we use in logarithms? 10. Okay? So it may or may not say 10. If it doesn't say a base at all, you know it's 10 because that's understood. Okay? So if I was given this problem, log of 2x equals 5, and asked to rewrite it in exponential form, I would write the base, which is 10 to the 5th power equals 2x. God bless you. And that could be some sort of equation I solve later. Right now I just asked for exponential form, so I'm done, right? Okay? But if there's not a base written there, then you know it's just base 10. So that's the common log. Okay? The natural log looks like this. Now, that looks completely different than all the stuff we've been writing. It doesn't even say log. It says ln. It does stand for natural log. That's exactly right. And natural log is log base what? E. Excellent. Okay? So I could rewrite this in this form. I don't, because all your mathematical friends will make fun of you. Okay? But if I was asked to rewrite this in exponential form, I would write e to the 5th power equals 2x. Now, writing it in this form makes that a little clearer, but again, your mathematical friends will frown at you and then laugh. We don't want that. Not me, because first of all, I'm not your friend, I'm your teacher. I'm just teasing. Okay. All right, but you know what I'm saying, right? Sorry. Everybody understand that? The thing about it is all the rules that we talked about, all of these, everything that applies to when it just says log also applies when it says natural log. Okay? So all the basic properties, for instance, if I said to you natural log of e to the 4th power, what does that equal? Well, natural log is really log base e, and if I have the base and the argument the same, what's the answer? The exponent. That just equals 4. Natural log of e to the 2x power, what does that equal? 2x. Okay? All these same properties, especially these inverse properties of logs, will be helpful and useful for you to remember. It's not just log that it works for. It's natural log as well, because natural log is the same properties as a common log, or log base 2, or any log like that. Okay? So if I have e to the natural log of x, what does that equal? Base and the base are the same. The answer is what's left. Done. Does that make sense? Okay? So, read over these objectives real quick in your head and make sure you don't have any questions on any of them. You good? All right. If you do have questions, come and ask as you're working through your homework, okay? Peace.